Hello and welcome to Turf Core Concepts. In this video, we're going to take a look at using Microsoft Excel to do some calculations related to top dressing after core aerification. I'll take a moment to pause the video and set your Excel file up to look like mine does here, and then you'll be ready to follow along. So we're going to use problem 3.3 on page 40 from the Mathematics of Turfgrass Maintenance to build this calculator. The question is, how much top dressing material is needed to cover 120,000 square feet of greens to fill 3/4 inch diameter by 3.5 inch deep core holes? The aerifier is set for 2 inch centers. So the first thing we're going to do is we're going to figure out how many aerification holes are created in 1 foot squared, knowing that we have 2 inch centers. We can look at this slide here and we see that in a single row that is 1 foot long, there will be 6 aerification holes. And then to find the square footage, we will just square the number that we get from dividing the centers by 12 by the centers. So in this problem, we're going to go to our spacings, highlighted yellow, and we're going to input our 2 inch spacing. Then to calculate how many cores are punched in a foot squared, we will use the equal sign. We'll open the parentheses, and it's going to be 12 for 12 inches in 1 foot divided by whatever the length of your center is. Close the parenthesis, raise to the power of 2 to square. And we see that in 1 square foot with 2 inch centers, we will be punching 36 aerification holes. The next bit of information we need is our area. So we're just going to set up our area calculation. So for, let's say we have 5 acres just for demonstration purposes here. So to get acres, 2 feet squared, we take our acre given and multiply by 43,560. And then I like to go both ways from foot squared back to acre. So if we're given foot squared, we will just divide to get back the acre. Right? And now the area highlighted yellow with thick outside border is going to be the cell that's dependent for the rest of the calculator. So we want to make sure that this cell is always filled. So in this problem, we're given 120,000 square feet. So just have this cell equal whatever acreage is calculated there to get our 120,000 there. All right, now we'll move on to the dimensions of the cores. So we're given 3/4 of an inch. So I'm going to put it in as the 3/4, and Excel will convert that to its decimal form. Then radius is 1/2 of the diameter. So we simply do equal sign our diameter divided by 2. And now we have our radius. And then the depth is given as 3.5 inches. Now we move on to calculating the volume of a single core. We use that volume of a cylinder formula, pi r squared multiplied by the height. So I'm going to go down to this conversions table real quick and just show you what Excel can do for the pi value. So if you hit equal sign and then just enter pi and then hit you can double click here and then enter, and it gives you an estimation of pi to 15 decimal points. You could just put 3.14, but if you have Excel, you might as well just use the function that's already available to you. Probably won't make too much of a difference in calculations of this size, but just want to show you that that's a possibility. So now let's calculate the volume of one single core. So our equal sign, open up a parenthesis, our pi multiplied. I'm going to put the radius squared in its own set of parentheses. So our radius raised to the power of 2, close the parenthesis, close the whole parenthesis of that first term before multiplying by the depth of the tine. And we get 1.5 inches cubed is the volume of a single core. Now we're going to find the volume of cores in a single foot squared, and we get this value by multiplying the volume of one core by the number of cores that are taken in a foot squared, and that's the 36 that we calculated earlier. Once we have the volume of cores in a square foot, we can move on to the last part of this calculator and finding the answer. We're going to find the volume of cores in our total area. So right now we have a volume in inches cubed per foot squared. So to get rid of those feet squared and just get a volume in inches cubed, we're going to multiply by our total area in feet squared. So that's going to be this 56 multiplied by the 120,000 squared that we're aerifying. And we get 6,679,811 inches cubed. So this is the amount of top dressing sand that will be needed to fill these holes. We're not going to go to our distributor and ask for 6 million inches cubed of top dressing sand. It's not going to be ordered that way, so we have to convert this number to yards, which is typically what you'll order this volume of sand with. So we're going to look at these conversion factors here. When you have cubic units, the conversions are all the same. There's still 1 foot per 12 inches. However, we cube that whole factor. Same thing with 1 yard to 3 feet. We're going to cube it. So this is essentially 1 cubed, which is 1 over 12 cubed. So we'll go down to our conversions again. Now I'm just going to show that to get inches cubed to feet cubed, we're going to be dividing the 6 million number by 12 cubed, which is 1,728. So our 6 million divided by 1,728 equals 3,866 feet cubed. And we're going to do one more conversion to get to yards. So as you see from this factor, it is 1 cubed over 3 cubed. So we're going to be dividing by 3 cubed, which is 27. I didn't put my equal sign, so it didn't. Now we get our 27. And we're dividing the 3,866 by 27. And we find a final answer of 143 yards of top dressing. And this is a number that can be ordered, and someone will understand what you're trying to get. So I hope this was helpful in making some calculations for top dressing sand. Thank you.